It's a machine we see pretty much every day, a silent workhorse of modern life that just carries millions of us up and down, and we don't even give it a second thought. We step on, we ride, we trust it. But what happens when that trust is completely, catastrophically shattered?
So how could something so ordinary, so reliable, suddenly become a death trap? Well, that's what we're here to break down. We're going to look at the terrifying story of one escalator that failed in the worst way possible and uncover how a marvel of engineering, something designed for safety, was turned into total chaos. In our story, it starts in Rome.
All right, let's set the scene. The date is October 23, 2018. Thousands of football fans are flooding the metro stations in Rome. The energy is electric, the crowds are absolutely massive, and they're all surging toward the trains.
And here's the scary part. It all went down in less than 3 minutes. At 7:03 p.m., the crowd just packs onto this one escalator, totally filling the steps. A minute later, the motor, straining under all that weight, just can't take it anymore. It hits its limit and loses control. That's the first line of defense. Gone. Then the second fails. By 7:05 p.m., the third and final safety system gives way. And the result is, well, it's a free fall.
People were just thrown forward, piling up at the bottom in this crushing heap. The steps themselves buckled and twisted into this horrifying trap of jagged metal. A disaster on this scale, it just shouldn't be possible. So, to really understand what went so terribly wrong, we first have to understand how these machines are supposed to work.
Escalators, as we know them today, are the result of over 100 years of fine-tuning, and pretty much every single component has been meticulously designed with one thing in mind: safety. Believe it or not, the very first escalator was actually a theme park ride back in 1896, and it was basically just a steep 25-degree conveyor belt. It was so weird and unsettling to ride that one department store in England actually had to offer brandy to men and smelling salts to women at the top just to calm their nerves. So yeah, the solution was to create a moving staircase. But the real genius is in how those steps actually work.
The big breakthrough came from a guy named George Wheeler. He gave each step 2 sets of wheels that run on 2 different tracks. When you're going up or down, the tracks are close together, and that keeps the step perfectly level. But at the top and bottom, the tracks spread apart. And this simple, brilliant design is what lets the step flatten out so you can get on and off easily, and then flip completely upside down for the hidden trip back to the start. It's just so clever.
And today's escalators are just packed with other little safety features you might not even notice. The grooves on the steps? They interlock perfectly with a calm plate at the end to kick any small objects out of the way. And those little brushes on the side? They're actually called skirt brushes, and their whole job is to keep your shoes from getting snagged in that tiny gap. Even the handrail is designed to move just a tiny bit faster than the steps to make sure it never falls behind as parts wear down over time.
But honestly, the most brilliant safety feature is also its most efficient. See, on a busy downward escalator, the sheer weight of all the people is actually what's driving the motor. The motor then resists that force, and that resistance acts as a perfect natural brake that keeps the speed constant. This is called regenerative braking. The motor literally becomes a generator creating electricity. It's super safe and it's incredibly energy efficient. So, with all of these layers of protection, the escalator in Rome should have been fail-safe. So how on earth did it go so terribly wrong? Well, the answer is this terrifying cascade, where every single one of those safety systems was just knocked out, one by one. First, the sheer weight of that crowd completely overwhelmed the motor's regenerative braking. That should have immediately triggered the second line of defense, this huge mechanical brake that's designed to just clamp down and stop the whole thing cold. But it didn't have enough force. It failed. So that left only one last hope, an auxiliary emergency brake. But, unbelievably, it failed too. Think about that for a second. In a machine designed with redundant safety systems, every single one was neutralized. There was nothing left to stop the stairs from plummeting. This wasn't just a case of bad luck. A 2-year investigation would soon uncover something far more disturbing.
As investigators started taking the wreckage apart, piece by piece, they began to realize that this wasn't an accident. No, this was the direct result of deliberate human actions and just gross negligence.
The evidence they found was just damning. They discovered the main brake was operating at only 37% of its required strength. The auxiliary brake, that final failsafe, had been physically tied off with plastic straps, making one of its two wedges totally useless. On top of that, critical error codes have been intentionally turned off in the software, and the maintenance records were either missing or just completely faked.
The investigation pointed to managers at the Transit Authority, ATAC, and the company they hired for maintenance. And in a chilling wiretap recording, one manager, Renato D'Amico, is heard just callously dismissing the risk. He says, out of 700 escalators, maybe 3 or 4 would fail. To him, it was just a numbers game, not about people's lives. This wasn't an engineering failure. It was a profound human one.
This whole horrifying story really forces you to ask the question, just how safe are these machines we rely on every single day? And how much trust should we really be putting in them?
The reality is, when they're properly maintained, escalators are incredibly robust. I mean, a single step is engineered to withstand a braking load of 1.5 tons. You could literally put an elephant on one step and it wouldn't break.
And to put the risk into perspective, in the US and Canada alone, we take over 100 billion safe escalator trips every single year. Catastrophic failures like what happened in Rome are almost unheard of because the technology itself is sound. The weak point isn't the steel or the software, it's us.
The Rome disaster is this brutal reminder that even the most brilliantly designed systems are completely vulnerable to human negligence and, frankly, indifference. And it leaves us with a really critical question. In a world that relies more and more on complex technology, our biggest responsibility isn't just to build safe machines, but to diligently and ethically maintain them.